Hi, it's me again, Franklin, and here I am again in my office. I wanted to take the time to give you a little bit of information about using pipes before the weekend to go along with assignment 2. In this video, I think I'm just going to really focus on writing code that uses pipes. And what we'll do is on Monday's class, we will take a look at the code that is written here. So we'll step through it and we'll try to get a sense of what our operating system is doing underneath to be able to support the implementation of pipes. This is code that I'm going to write that's in the interprocess communications Git repository that I put up on the course webpage. And I will push any of the code that I'm going to write in this video up to that repository so that you have access to it. I wanted to get this to you before the weekend so that if you are able to get past the basic launching of processes stuff with the assignment over the weekend, that you could proceed to working with pipes if you wanted to. So let's take a look at my terminal. We're going to be working in this inter-process comms directory, and the file that we're going to be working with here is called pipes.c. The whole purpose of this program is that I want to be able to run pipes here, and I want to be able to send the name of a program that I wanted to launch. And what this program should do is take that program and take the standard input for the process that I'm launching, that's my own program, the standard output for this program, and replace this program's standard input with that. So cat is a simple case here. The other programs that I might want to do are things like head-5. Head-5 is going to be a program that will take the first 5 lines. The -5 here is going to be, this is how many lines of output I want to produce before I stop running. I'm going to take a look at pipes.c itself. So the way that pipes.c is initially set up here is that we've got our 3-argument version of the main function. We're not going to use nth anywhere here. We're just accepting that it's something that we're taking as input to the main function, and we're going to pass through to the exec function that we're ultimately going to call. argc and argv are normally what we would get in a main function, and argv is going to be where the commands are that we're taking as input for this program. The first little bit of this is not super interesting. It's checking to see that we're actually passing an argument to this. There's one addition that I've added here, which is to have sig pipes default action be sig ignore. By default, when we call write on the right end of a pipe, which we'll see in a moment, if I call write on the right end of a pipe that is closed, I will get this signal sent to me, and I don't want my process to actually stop. So the default action is for a process to end, and I don't want it to do that. So instead, what I'm saying is replace the signal handler for sig pipe with sig ignore. And this is a default OS supplied signal handler that says just don't do anything with it. So kind of like what we were doing in class with the printf, but in this case, it literally just doesn't do anything. To get the arguments of the command that I want to work with. So when I ran this on the command line, I'm passing this something like pipes and then cat like this, or pipes. And another example is tr A to Z and A to Z like this. TR is a program that will take lines of input and it will do replacements. So this will take all of the lowercase letters and replace them with uppercase letters here. Split is a function that you are welcome to use if you want to for your own implementation, that will take a white space separated string and it will return an array of string array. A string array, it will return a string array for us. So it would be an array of pointers, double array, double array, double pointer. The place that we actually want to start doing stuff here is right in this point where we're going to want to do some piping. So we're going to call a function called pipe to help us with this. What pipe does is it will establish a way for 2 processes to talk to each other using file descriptors. What pipe as a system call takes as an argument is an array of 2 integers. These 2 integers will represent the read end of a pipe and the write end of a pipe. We're going to be able to read from this pipe and we're going to be able to write to this pipe. Conceptually, this is a little bit like having a file that's between two processes, which was an example that came up in class today. A file that's between two processes where one of them is writing to it and the other one is reading from it. The main difference between pipes and files is that when I call read on a pipe, read is a blocking operation. So in the same way that calling getchar or trying to read from standard input is a blocking operation, calling read on a pipe will cause my process to block until there's actually data on the other end of the pipe, on the right end of the pipe for me to work with. So the first thing I'm going to do here is I'm going to declare an array of integers that is 2 elements long. I'm going to declare that way up here at the top of my program, int pipe ends, and it's going to have exactly 2 elements in it. I'm going to initialize these to 0 just for the start of it so that I know that they're not populated with anything once I'm working with them. Once I've declared this array of integers, now I want to call the pipe system call. So I'm going to say pipe ends like this. Ask the OS to create 2 new ends of a pipe. 1 pipe. So this will create 1 pipe, but the 2 integers that we've got will be one end of the pipe and the other end of the pipe. I'm doing this before calling fork. I'm doing this before calling fork because this is manipulating my open file table. And I want both processes to have entries in the OFT for this pipe. So piping, remember, is inter-process communication. The goal here is to be able to communicate between 2 different processes. I'm going to call pipe before I call fork to create an additional process so that I've got 2 entries in my open file table that represent the read end and the write end of the pipe. Now that I've called pipe, I'm going to say that the process ID of the child is fork. So I've got PID here. I want to fork a new process. So PID is equal to fork. And then I'm going to ask a question. If PID is equal to 0, then I'm in the child branch. I'm not actually going to do an else part of this statement because ultimately what we're doing is asking the operating system to replace the child branch with a different program. So the end goal here is I want to be able to say exec VPE CMD args. So that's the split thing that we have. That's going to be cat, or it's going to be TR. I want that to be the first thing that I'm launching here. I'm going to pass the entire array. I'm doing this just for convenience sake, as opposed to having a hard-coded version of this or a separate version of this. And then I'm going to do envp. I want to pass the array of environment variables that have been passed to my main function without making any changes to those. So in the child branch of the fork, this is where I'm going to do launching of the process. Remember that as we saw in class, we never return from this. So I don't really have to worry about calling exit or doing anything else with this because as soon as we launch this, it's never going to return control back to our program. In the child branch of the fork, what I want to do now is I want to set up the child process so that its standard input is going to be one end of the pipe. The end of the pipe that I want my child process to have its standard input be is going to be the read end of the pipe. And so what I'm going to do is in the child process, because I'm only using the read end of the pipe, I'm going to close the write end of the pipe. I got a file descriptor back from pipe, and I'm going to close the file descriptor that I'm not actually using. So close pipe ends at element 1 here. Close the right end of the pipe in the child process. I'm never going to write to the pipe, so I want to make sure that it is closed. What I want to do then is I want to replace the file descriptor for standard input in this process with the read end of the pipe. To do that, I'm going to be using another system call here that's called dupe2. Dupe2 is a way for us to manipulate our open file table by taking existing file descriptors and replacing them with other file descriptors. So my goal here is that I want to take the file descriptor that is the read end of this pipe, and I want to replace standard inputs file descriptor in the open file table. Recall when we were visualizing the process control block, we did this and we showed that standard input, standard output, and standard error were just entries in the open file table. They were just file descriptors. So I'm going to use dupe2, and I'm going to replace the file descriptor for standard input with the read end of this pipe. So I'm going to say pipe ends at 0, and what I want to replace is stdin file no. So what this says now is replace the file descriptor in the open file table for just this process. So we're currently in the child process, so just this process is open file table. Replace the file descriptor in the open file table for just this process for standard input with the read end of the pipe. Now this is cool. Like, I can now start to take pipes, I can start to take other files, and I can just replace what that program believes to be standard input with that file descriptor. And that's really powerful because I don't necessarily have control over the content of cat. I don't know how cat is written, but I do know that cat reads from standard input. I don't know how tr is written, but I do know that tr reads from standard input. And so I'm able to replace the standard input file descriptor. I'm able to manipulate the open file table. And in this case, what I'm doing is I want to replace the standard input file descriptor with this pipe end. So the read end of the pipe that I created up here with the pipe system call. After that, then I can start ask the OS to replace my code section with the program that I'm trying to run from the command line. So cat, for example. After I call exec VPE here, or exec, or fexec VE, or any of those exec variants, the changes to the open file table will persist. So I've replaced standard input file descriptor with the read end of this pipe. As far as cat knows, in exec VE here, when I start running in the main function of that, it doesn't need to know, and it doesn't know that standard input is the read end of this pipe. It will just work. It's just going to read from standard input file no. The other half of this now is that I have to start writing data from my parent process to the right end of the pipe. When cat starts and it starts to read from standard input, it's going to block and it's going to get stuck, and it's waiting because nothing has been written to the right end of this pipe. So in my parent process, what I'm going to do is I'm going to close the read end of the pipe. I'm not using the read end of the pipe in this process. Close the read end in the parent. We're not reading from this pipe. We're only going to be writing to this pipe. So close the read end in the parent. We're not going to read from this pipe. I don't need to manipulate my own open file table in the parent process because I actually want to read from my own standard input here. So the way that I'm going to accomplish that is that I'm going to write this loop that says while read, and I'm going to read from standard input. And this is approximately what that read command would look like in cat itself. I'm going to read from standard input. I want to read into a buffer. So I'm going to read 1 byte at a time here. And while it's greater than 0, I'm going to take the buffer that I've read and I'm going to write it. And what I'm going to write it to is pipe ends at 1 byte. And I want to write 1 byte to this thing. So write the byte that we read from our own standard input to the right end of the pipe. This is actually approximately what the loop would look like for a program that's reading from standard input like cat or like tr. It's going to call read on standard input file no. It's going to read usually more than 1 byte at a time, but it will read. It will write to standard output instead of the pipe end that we have here. And then it will read, and then it will write, and then it will read, then it will write. And eventually what will happen is we will get to the end of the file. There will be no bytes read from read despite asking for 1 byte to be read. The last part of this now is that once I've finished writing all of my standard input, so there's nothing left on my standard input to read, then I'm going to close the right end of the pipe. The goal for closing the right end of the pipe is that we want to close the right end of the pipe in the parent process because anyone holding the read end of the pipe open will unblock from read when there are no write ends open. So when cat is in its own loop that looks like this one, is calling read on the read end of the pipe, which we've replaced standard input with, it's going to block if there's any right end of the pipe open. As soon as we close the right end of the pipe, read will return, and it's going to return that 0 bytes have been read, and it will exit the loop, and it will then proceed to exit the program. The very last thing that I want to do is, as a responsible parent, I want to wait for my child process to finish, and so I'm going to block here until that child process has finished. I'm going to go up to the very top of my program because I realized that I didn't include that GNU source thing. So I'm going to say number define underscore GNU source. This will be here for you. Again, we don't have to worry too much about it. This is a really hyper Linux specific thing that I don't care too much about. I'm going to write this code out. I'm going to quit my manual page here. I'm going to change into this directory. I'm going to make this. I forgot to declare a variable that's called byte. So I'm going to say char byte here. And I'll initialize this. Whoops, I'll initialize this with the null byte. I'll make this one more time. And again, the way that I want to run this program is I'm going to say pipes, and I'm going to say cat here. So what's happening right now is I have pipes is running, and I have cat is running. Pipes has called fork and exec on cat. Both pipes and cat are blocked. They're both blocked waiting on reading their standard input. My code, pipes, right now is blocked on this line right here. This is line 80 of my code, and it's waiting for me to type stuff in on standard input. Cat, again, we actually don't know what's in cat, but I can tell you for certain that it's a loop that looks almost exactly the same as this. It is trying to read from its own standard input, which we have replaced with the read end of the pipe here. And it's blocked because there is a right end of the pipe open somewhere. If I type something into this, hello world, and I press enter, my code is going to unblock from read. It will unblock from read for H, and then it will write to the right end of the pipe H. Then it will read, and it doesn't need to block here because there's immediately something for me to read. We'll get E, and then we'll write E to the pipe, and then L, and then we'll write L to the pipe, and we'll read O, and we'll write O to the pipe. And we'll continue until we get to the new line character. Cat is, again, also kind of stuck. It's blocked here. And as we are writing to the right end of the pipe, its read becomes unblocked. And it will also print to standard output, whatever it is going to print out. I'm going to hit Control D on my keyboard. And what Control D says is there's no more input. My read will unblock, but it's going to return that 0 bytes were read. When 0 bytes were read, we close the right end of the pipe. Closing the right end of the pipe causes read in cat here to unblock and do the same thing. It's going to return 0. There were no bytes read here. I'm going to run this again, but this time I'm going to run tr A to Z and A to Z. This is a program now that should take any input on its standard input, or whatever it believes to be a standard input, and replace all lowercase characters with uppercase characters. So I'm going to type in hello world here again and press enter. And again, right now, or initially, right now, our process pipes is blocked on read, and it is waiting for us to type something in on standard input. I typed in hello world and pressed enter. And then repeatedly, it reads 1 byte from standard input, and it will write that 1 byte to the right end of this pipe. TR now, not cat, so TR is reading, but again, similar to cat, it's got a loop that looks a lot like this one. It's reading that character in, and it's going to replace it with its uppercase version. It reads the next character in, and it's going to replace it with its uppercase version. And then eventually, it's going to get also blocked on read, waiting for more input on its standard input. When I hit Control D here on my keyboard, I'm telling this read there's no more data left, so read will unblock and it will return 0. There are no bytes that were read. We will close the right end of the pipe, and that will cause cat, or TR in this case, to have its own loop that looks like this: return 0, unblock and return 0, and then proceed to exit, so that when we get to our wait here, our child process will have exited. That's it for pipes in terms of using pipes from a piece of code. And I hope that that was helpful. Again, we'll take a look at this code in class on Monday, but I wanted to make sure that you had a chance to take a look at this before that, if you are able to get to that point in the assignment.